screen. I'll share the screen. Okay, and welcome everybody to Big Data. Good afternoon. A lot of class sessions. Most of them I'm going to start with having some sort of schedule up here and go over, I don't know, various things. This is just to remind me mostly what's going on. I have it opened up in Vim right now. I do everything in Vim, not just coding. I write emails, I write documents, I do everything inside of Vim. So I write my schedules inside of Vim. Here, the first thing that we'll talk about today is just a postmortem review of the lab. Zoom is doing that. Handful of people doing pre-lab work during a lot of time. I'm totally okay with that. Or a handful of people not attending in person. I'm totally okay with that. So you all should feel free to do whatever you feel is the most efficient use of your time. But I've tried to structure the labs and the pre-lab thing so that it'll be most efficient if you do the pre-lab stuff beforehand and the lab stuff during lab. Again, all the labs, this first lab, there's nothing to turn in, so no way to be late on the lab. But all the labs will be due on Sundays at midnight. There's also a homework for this topic 0, and the homework is sort of nominally due tomorrow at midnight. I will go over everything that you need in class today to complete the homework assignments. But there will be no late penalty for this first homework assignment as well. So if for whatever reason any of these early topics you are running into questions and aren't able to finish it in time, no worries, won't affect your grade at all. You can you'll have plenty of time to ask about them. One thing, up here, ensure that you are watching the course repo. So again, over here, I have the course repo pulled up, and there's this watch button up here. And there's still a handful of students who haven't pressed this watch button on your account. Strongly recommend you do that so that when people post issues over here, whether it's me or another student in the class, you'll get notified about that, and you can get various questions and things answered. So if you haven't done that yet, press this watch button. Mine says unwatch because I'm already watching, but press this up here. And in particular, you'll want this all activity section. I've gotten a handful of emails from people in class. I've tried to respond to all of them so far, but in the future, from this point forward, I won't be responding to your emails. If you email me something, I will almost certainly tell you to post it as an issue on GitHub, and I'll respond on GitHub. And the purpose of that is twofold. One is to get you more practice using GitHub and using it to collaborate on different projects. But the other purpose of that, the more I guess typical purpose, is just so that everybody in class can benefit from your questions and my answers to them. The only exception to that is if it's a very personal question, for example, about what your grades is, why something was graded a certain way, that would be appropriate for email, but anything else appropriate for GitHub issues. Last thing about this, since it's related to issues, I want to talk real quick about the markdown formatting involved in the lab assignments. And one of the things that you're supposed to do is under the issues tab, there was this meet and greet thread down here. Open up, here we go. And you're supposed to post some sort of message like this. And I just want to highlight the difference between what some correct and incorrect postings look like. And I'm not doing this to try to call anybody out or anything, but if you do post issues in the future, I'm going to enforce that you've posted them with correct style before I answer them. And the reason for that is so that when you go online to other people's issues, something not related with this class at all, that you are using the correct style that people are expecting. Because if you do that, then people will say, oh, this is like a serious person that I'm talking to, and they will want to help you out. But if you're not using correct style or correct language about things, then people will be less inclined to help you out in the future. Future employers who are browsing your GitHub will be less inclined to take you seriously. And so that's why I'll be enforcing correct style issues. So here, the main thing is that I wanted everybody to be aware of at this point is the difference between the single quotation mark and the triple quotation mark backtick. Single backtick versus triple backtick in GitHub or in Markdown in general. The single backtick is for inline code in a paragraph like this. So you only use the single backtick if you're like quoting something in the middle of a paragraph. Anytime you're actually like, it's a full line of code or multiple lines of code, it needs to be the triple backticks like this with your code in here. I don't know, something like that. And so over here, just an example of what the difference looks like here. This is with the single backtick. This is with the triple backtick. This isn't, I don't know, I can still read what's going on here, but that one's not too bad. Some more single backticks. One thing to be aware of too is that if you have long lines inside these code blocks, it requires people to scroll. So it's traditional to limit your lines to be less than 80 characters, and then it'll always not require scrolling on anybody's screen. This is another example that it's, we just want, if it was in the triple backticks, this would be a lot easier to read right here. So you'll never lose points or anything for, it's never like a graded thing about getting formatting right. And, but it's just a good habit to be in so that you can get your questions answered efficiently. Posting on other people's GitHub repos or ever if you're asking on Stack Overflow uses the same Markdown formatting. Any questions before we go on about anything from this lab material? Okay, maybe one last comment. A couple of people asked about attendance sort of things. Again, I don't really care whether you prefer to attend in person or online. Again, all these lectures recorded will be posted on YouTube so that you'll have access to them. So if it's more convenient for you, more efficient for you to do that, that's fine with me. But we will have the regular Wednesday quizzes, and so you'll want to be here in person for those. So again, next Wednesday, next class period, we'll have our first quiz in this class. The format for these quizzes, all of these quizzes, will be that you will have 8 minutes of class time to complete the quiz. And if for whatever reason you prefer to have more time than that to work on the quiz, I will be in class early. I will be in class about 16 minutes early. And anybody who would like more time can come early and start your quiz early. I think this is, I tried to schedule things, design the quizzes, so this is plenty of time. Takes me about 30 seconds per problem working slowly. But I don't want anybody to be time crunched on this. So it should be plenty of time for everybody to complete the quizzes. One other comment I have about this, so I've written these numbers here, like I pronounced this in words as the number 8, and I pronounced this in words as the number 16, but I've written it in this like 2 raised to the power format in this exponential format because powers of 2 are super important in computer science, and it's good to be familiar with those. And so anytime in this class where I'm giving you numbers, I'm always going to be doing it in this format right here, just to get you that practice, intuitive feeling about what these power of 2 numbers are like. And so if you go back over to the quizzes, for example, this practice quiz C, one that I tried to hand out again last week, but the printer broke, so this one didn't get printed. There's more copies up front if you would like one. But on your quiz, it's going to be out of 4 points, and I'm not going to write that it's out of 4 points. I'm going to write that it's out of 2 squared points. Again, quiz will have 4 problems. These problems are formatted where you just type in these commands into the Lambda server, and what you need to write out is just what the output of this final command down here is going to be. I have 3 of these practice quizzes so that you can try various different variations of the problems. Great question. The question is, on the actual quiz, will you also have four problems? And the answer is yes. You'll have 4 problems where each problem is just varied from the problem in the practice quizzes according to the note down here. Whatever the little formula I have is for modifying problems, I'll do that, create a whole new problem, and that's what you'll get on the actual quiz. So 4 problems, each worth 2 points. Sorry, each worth 1 point. The quiz out of 4 points. And if you can do all the practice problems, you should be good on the actual quiz. But if you want even more practice, you can generate your own problems following the little algorithms down here that describe how I'm going to create the new quiz problems. Any questions on what to expect for the quiz on Wednesday? Okay, at this point, we've covered everything that's going to be on the quiz. So you should be able to work through these problems, and the material we'll be going over today does more GitHub stuff, so it will reinforce some of the quiz stuff, but it's not stuff that will be on the quiz itself. Last part down here. So I said last week, we really haven't gone over the syllabus yet. We're going to do that today. Also going over the idea of pull requests at the same time. And all the stuff up to this point has been following along with the CS46 course, the data structures course that I teach. But at this point, maybe at the end of today, but definitely by Wednesday, we'll be diverging from that and getting into the more big data specific stuff. So coming over to our class webpage again. So github.com/mikeisbicky/cmc-csci143. This is where all the stuff on the course will be posted. And in particular, this first README file right here is our syllabus. And so all this stuff down here is syllabus related stuff. I'll just do a quick, before we get into the super boring stuff that everybody's going to fall asleep for, maybe this will career stuff interest people. You click that link, there's a career.md file in there that has some links that people might be interested in. My sense right now is that it's actually a really good time still to be mid-senior level programmer, and it's a pretty typical time right now to be entry level. But there's a lot of people talking about layoffs at big tech companies. But my sense is that hiring is still actually outpacing layoffs, and that the amount of hiring right now is basically the same as the amount of hiring that was happening during pre-COVID times. There's just a huge surge in hiring during COVID times, and so companies are sort of getting back to sort of average environments. If you want to take a look at like who's actually being laid off, then that link right there will tell you, and it's a lot of like sales people and product design people, and then like the engineering people are very relatively few in the actual amount of people being laid off. Where am I? I'll let people browse. Well, no, I want to talk about this a little bit. So about salaries in this class for the sort of things we're going to talk about in this class. Again, the big picture idea of what we're doing in this class, down here in this picture right here. What we're working up towards is the idea of being able to run multiple machines off in the cloud somewhere that you don't have direct access to, maybe that you don't even own, and coordinate all those servers working together. The people who are doing this would be typically called DevOps or distributed systems engineers people. And their salaries are tend to be higher than typical software engineering salaries. So here's the average of distributed engineering people, 226,000. Here's an average of software engineering people, 172. So I mean, both pretty good. And then in general, people who have the data scientist label a little bit lower than the software engineering label, but still pretty high up there compared to a lot of other jobs. And even though there's been all of these various layoffs happening, it still hasn't really affected salaries at all. Stock prices are a little bit down, so that affects the stock bonuses, but not the actual cash that people are receiving. So there's more links about that if you're interested in those things. But back to the actual course. So more about me, again, Mike is Bicky, prefer to go by just Mike though. All the things in this course really designed to help get you that good job after you graduate. And so one of these things is me going by Mike, that anywhere where you're working, at a software company, your boss, all the way up the chain of command, as long as it's technical people, they're all gonna be on a first name basis. Nobody ever called Bill Gates Mr. Gates. He was always Bill to his employees. Similarly, like Mark Zuckerberg is Mark, and so on. So a lot of people, it is maybe uncomfortable calling your professors by your first name, but that might be in the future uncomfortable calling your boss by their first name. And so this is trying to help you get into that cultural mindset of calling people by their first name. My office hours, I haven't posted them yet because I still have a couple of things that need scheduling, but I will post this sometime this week, and there'll be an issue about it so that you can, if you're watching the repository, you'll get an update about that. If people have questions though, anytime this week before the office hours are posted, feel free to post your questions to GitHub issues, or if you have questions right now today, I'll stick around after class as long as people have questions and get all those things answered. Few real quick fun facts. So I grew up pretty close to here in San Clemente, about an hour away, 7 years in the Navy, was a nuclear submarine officer, worked for the National Security Agency. Both of these two things will have various stories that come up throughout the course. I think I mentioned a little bit about that last time, Monday, but ended up leaving the Navy as a conscientious objector, feeling like what I was doing wasn't making the world a better place. Happy to talk with people about any of these things in the future if those career paths are interesting to you. Did a postdoc PhD at UC Riverside, also pretty close to here, and taught and actually continue to work with North Korea in a program to help North Koreans and ordinary Americans work together to improve relations between our countries. Turns out that a lot of problems that have happened between the countries are related to computer science things, and that's another thing that we'll talk about in a little bit when we'll talk about Unicode stuff later on in this course. So how foreign languages get encoded, and North Korea is very bitter about Unicode support for their language. And then last thing, the thing that actually mostly relevant for our course, my wife's currently pregnant, due to have a baby April 18th. This is exactly 2 weeks before the last 2 weeks of the semester. And so I'm planning on taking a 2-week paternity leave when the baby comes. If the baby comes on time, then there won't be like any modifications to what the course schedule is. But if the baby comes a little bit early, we'll have a 2-week break and then get back to the course after that. So the last month or so of the course, a little bit up in the air in terms of timelines for things, but yeah, I'll try to work with you all on that, and it hopefully shouldn't be too much of an issue. Any quick questions about me or anything before we, actually one last thing about this. So related to the timeline thing, the way that the course is organized, if you're curious about what we're going to be talking about in the future, there's this future folder right here that has the basic list of topics that we're going to be covering. And I'll be moving, you don't ever have to look at this if you don't want to, but this is roughly the topics that we'll be covering if you're interested in seeing ahead. There's a lot of like SQL and database stuff, but I'll give it, yeah, a little bit more of an outline of that in a little bit. Any questions about anything so far? Okay. Yeah, it's all, I don't know, kind of boring, non-technical stuff. We'll get to some technical stuff here in a little bit. So I guess this is sort of technical. What is big data? So really, this course was designed to help the students in the data science major complete the capstone projects that companies want to work with us. And so, for example, last semester, we were working with Disney Plus on analyzing all of the user activity on Disney Plus. And so the data set that they had for us was about like 2 or 3 terabytes. And in my opinion, I consider that to still be small data. At that point, you still need to like have a little bit, I don't know, awareness of the space complexity of things. But companies like Facebook, for example, they're ingesting, the last public report Facebook has about this is from 2014, and they were ingesting about 20 petabytes an hour in 2014. So a petabyte is 1,000 terabytes. And so, yeah, and that's a decade ago. So at this point, there's no like official thing I can link to, but it's probably on the order of exabytes per day, like 1,000 petabytes per day, which is 1,000,000 terabytes. And so that's, we're not going to be talking about that scale of things in this class. We're going to be talking really about the, what I consider to be the Muggle version of big data that's like anything bigger than a gigabyte. So like a 1 gigabyte to maybe 100 terabyte sort of range. Yeah, I think that rest is just the summary of things that I just said. In this class, there's 3 main data sets that we'll be working with. This first one here is a CMC specific data set, all geolocated tweets set from 2017 until today. So it's on the order of trillions of tweets. It takes up about 4 terabytes of space, and we'll be talking about how to access that and work with that efficiently. So after this class, if you wanted to compete with Elon Musk and start your own Twitter service, you would be totally equipped to be able to do that efficiently. 2 data sets that we normally get to work with, but may or may not this semester. I've X'd them out here because we should just plan on not being able to work with them, is the Common Crawl and Internet Archive. So larger data sets about actual internet stuff. The main reason why I'm not sure if we'll be able to get to these is because we're doing a little bit more review of CS46 material based on how previous semesters worked out for most of the data science students. One of the reasons why we're doing three class sessions, having the extra lab at the end of this, at the end of every week, is to make up for the 2 weeks that I'll miss from up here. But it comes out to that we'll have a little bit more than 2 weeks additional time based on that. So we might be able to add this in, but maybe not. So big, like final big goal that we're getting to, building your own Google search engine that can process these large terabyte, petabyte level data sets basically instantly. Google has as their goal for any web page, both in their own system and in the internet at large, that you have to be able to return results to users within 200 milliseconds. And if you're building your own web page and you're slower than that, Google will not rank you very well. And all Google web pages meet this requirement. So we'll talk about how to meet that. And in particular, about 3 weeks from now, if we were to click on this future thing here, we're going to be starting with what I call the Instagram tech stack. In about 3 weeks, you'll build your own version of Instagram. It has all the services that Instagram has on its back end. And this will be involving a lot of the bash shell programming stuff that we're talking about, or that we did talk about last week, and will continue this week. Back down here. Yeah, so I'll just go over these technologies super fast. So some of the things we'll be using: Docker containers, various database systems. Main one here is Postgres. I'll be talking about a high level about the difference between Postgres and other things like MySQL, SQLite, Oracle, Microsoft's SQL Server. And I'll make the case that this really is the best thing that exists. With Postgres, we'll be able to handle up to the exabyte level of data pretty efficiently and reasonably. And this is exactly what Instagram uses. So if it's good enough for Instagram, then it's probably good enough for us. And then, so with these technologies, one last thing is that, so other students past students have made cool websites, little businesses. So here's one from 2 years ago, if you're interested in taking a look at that or starting your own. Any questions about what's going to be in this course? What to expect topic-wise? Okay. Quick thing about who should take this course. So again, designed for data science majors. Really, the way that I see this course is that this is the last actual programming course in the data science major. And so I see my job as making sure that you know everything that you need to know as part of the data science major. All of you other computer science majors or other people, very welcome in this course, but my goal is to target all the data science majors and make sure that you have been exposed to all the things in computer science that you should be exposed to. A lot of overlap with the CS 133 databases courses at MUD and Pomona, but this course a lot more practical. Some students like taking both courses, some students don't. I'm going to skip over the prerequisites and the relation to other CS courses. Textbook, everything's going to be free in this class. You don't need to buy anything. And jump down here to grades, things that people will be maybe interested in. And so grades divided up into these 5 categories. Weekly labs, you've already seen roughly what the format of those look like. Weekly quizzes, we'll have our first one next week. And again, all the point totals for everything here are in this exponential notation, just so that you get more comfort using these things. So this first quiz will be worth 4 points. Other quizzes might be worth 8 or 16, depending on like how much review topics they'll be covering and at what point they come in the semester. And but you'll know well in advance what quizzes are worth what. Projects worth 8, 16, or 32 points each. And then in this class, 4 exams worth 256 points each. That's a lot, and I think that's unreasonable. So we're going to go through the process now of issuing a pull request to change this value to a more appropriate value. And at any point in this class, if there's anything in any of the assignments or like due dates of assignments or things that you want changed, then you can always go through this process and change those things yourself to be more reasonable values. So yeah, we're gonna pause our discussion of the syllabus here for a second and actually change the syllabus to changing this thing right here to something more reasonable. Before we do that, there's a question. Yes, Maria. Projects, homework, same thing, yes. Good question. Okay, so yeah, we're gonna walk through the steps of submitting a pull request and changing this now. Right now, I'm logged into my normal Lambda server account. If I come up here, click this, you can see I'm logged in as Mike is Bicky. That's just what my GitHub account is. If I come over to this other Firefox terminal now, though, I'm in a private window, so I can log in as a different user. And here I'm just logged in as CMC example student. And also what we're doing is going to be with this, we're going to be going over this cheat sheet right here of steps of submitting a pull request. And so this would be just a good thing to have as a reference out, especially if you've never done this before. We're going to be walking through these steps right here. In this little cheat sheet up here, each one of these like cloud little things is a web page, and any arrow that goes between cloud things is something that only happens on the web page, not in the actual Lambda server in the terminal. And here, this box right here is the Lambda server. Any arrow that's coming into or out of the Lambda server is something that you do on the Lambda server and not on the web page. This first cloud up here is, so I have this label upstream right here. It's called the upstream repository. And this is the repository that we want to issue a change to. So this is our class repository right now. And we want to issue a change to this repository saying that 4 exams is too much, 256 points each, too much, and change that actual value. In order to do that, our first step right here is going to be fork that and create our own new repository. Before I do this, I want to highlight that, so back in the CMC example student window right here, so I can't edit this directly, but there is a interface in GitHub where I can try to modify these files through the GitHub interface and submit a pull request through the GitHub interface. For this class, anytime you're submitting a pull request, that won't be allowed. You'll have to go through this more long form process and doing things on the Lambda server because for 2 reasons. One is that I want you to get more experience with working with the terminal down here. But the second, probably more important one, is that the more complicated pull requests, the more advanced things that we'll be doing with GitHub will require you to be doing this long form process. And so I would just want you to get into the habit of doing this. So this first step, going from here down to here, forking the repository, just clicking that button up there, it'll ask you something like this, create a new fork, and the green button down here, create the fork, and there we go, it's working. As it's doing its thing, just a quick poll of the class. How many people have used Git and GitHub, like creating pull requests from the command line before? Handful of people, okay. But most people not, okay. Yeah, so this is, again, something that I normally go through. We do in the CS46 class, the data structures class here. But we're, but it's, yeah, doing it right now. Okay, so it's created our fork down here now, and I know I'm on a forked repository right here because right below the repository name up here, it's telling me that it's forked from, and here's the original repository. So this repository right here corresponds to this one over here. The repository that says forked from down here corresponds to this one down here. I know one other reason I know it corresponds to this repository down here is that this thing in the cloud is supposed to represent the URL that we're looking at. So it's github.com/u, so whatever your username is. And it might be hard to see the URL up here, but inside the URL is this right here, the actual user account that I'm logged in at. If I were to click the back button, it'll go back to the original Mike Isbicki repository, but we're on what we need right now is the CMC example student repository. And that's all of step one. That fork process actually creates this new repository down here, and we'll be referring to that repository as the origin repository. All the other steps that we're going to be doing next are in this loop over here that'll happen on the Lambda server. So I'm going to open up a terminal window now. And right now, I know that I'm not connected to the Lambda server because on my terminal, and this is going to be the same for your terminal on the Lambda server after you've done the first lab, the thing to the left of the colon over here is whatever computer I'm currently connected to. So I'm currently connected to my laptop. And in order to get my command to run the Lambda server, I could go back to that email and find the details. Or again, I can always search my history using the Control-R command in the terminal. Brings up this reverse search. And if I just start typing my, my user account, then it'll bring up the last command that contains whatever the string is that I typed up here. So I just typed in 143 for the class number, and that brought up this command. I don't have to memorize this giant IP address. I don't have to copy it from the email every time, or the port number or anything else. Hit enter, type in my password, and I'm typing my password correctly. There we go, and we get logged in. And again, throughout this course, when I'm working on the command line, I'm going to be mentioning a bunch of little shortcuts like this Control-R thing that I personally use very often. I'm never going to test you on those things, though, but they will be useful for you. In this course, you're going to be in the command line here for well over 100 hours throughout the course. And so the more of these little tricks that you pick up about using the command line, the more enjoyable the experience of using it will be, and the more productive you'll be. So again, that was Control-R for searching. The R stands for reverse. So you're searching in reverse order throughout your history. Now I'm in my Lambda server right here. If I type pwd again, that gets me to my home folder. ls tells me all the things inside of my home folder. And when I am working on projects on any computer that I work on, I always create a folder called proj and put all of my projects inside that folder to help keep me organized. And all of these projects, I use GitHub as like the cloud storage, sort of the backup or the way to share with people. But I do all the work actually in the terminal. And the way the first step for communicating between the terminal and GitHub is this git clone command right here. This step 2 that goes from this, basically taking stuff from the cloud and cloning it onto the Lambda server. The way you use this command, come back over here, we type git clone, and then the URL of the repository that we want to clone. The important thing here is there's, if you click on, so yeah, two important things. The first is make sure you're on the fork, on the origin repository, and not on the upstream repository. So we're on the origin repository here. I know that because it has my username right here, the student username instead of the instructor username right here, CMC example student. And it also tells me forked from right here. I'm also on the home page of this repository. So you can get to the home page by just clicking this button right here. And I'm going to take this URL up here and copy that entire URL. If you're on one of these other pages, the URL will be a lot bigger and it won't work. So make sure that you first click this button right here to get to the home page of the repository and use that URL. Then you come back to the terminal and paste that URL in. If you are on Windows using PuTTY, then the way to paste into PuTTY is to right-click. Whatever is in your keyboard will be pasted when you right-click. And if you are on any other system, then pasting is normally done in the terminal how you would paste anywhere else on your computer, unless you have a weird setting set somewhere. So I just pasted here on most Linux systems. You can paste just by middle clicking. And so that's what I did. And git clone that, hit enter, and it will download all of those things. If I type ls now, then there'll be one thing inside of this folder, which will be the CMC 143 repository information. And I'll cd into that, type ls. And all the things that we see down here, all of these files, are the same exact files that we see if we come back to this forked repo and looked right here. Maybe it's not quite exactly the same because there's things like this .gitignore file right here that did not get displayed when I did ls down here. That's because I did just ls by itself. If I do ls-a, again, the -a will give me all of the files, and all files beginning with a dot or beginning with a period are what we call hidden files or dot files in Unix. And so these do not get displayed by default. They are hidden by default. But when I do the -a, it's going to display those files as well. The dot and dot always exist in every folder. The .git exists only in Git repositories. This is what makes something a Git repository, is having a .git folder in there. And then these two things are special things about Git that we'll talk about at some later time. Good time to pause and come up for breath if anybody has questions about what's going on so far. Good way, I don't meta comment, good way to take notes about these sorts of things are anytime we're doing something that has a corresponding cheat sheet, to have that in front and taking the notes on that. Or just working, like having your laptop up and following through with the same sort of commands as I'm doing them, and making sure that you're getting similar outputs to what I'm getting. Good ways to work in this class. But again, if you are trying to follow along and somehow you miss a particular step, then that's okay. All this will be available on YouTube later today that you can go watch it and pause it at the key moments to make sure that you're getting all the commands exactly as I get them. Question, yes. Great question. The question is right here, what exactly is this 2023 spring? The answer is, so I'll go over what this entire prompt is. And this prompt is only, your prompt is only going to look like this after you have completed the very first lab. And if you have completed that and your prompt does not look like this, then it means that something went wrong, and we should take a look at that to get this fixed so it does look like mine up here. To the left of the colon over here is the name of the computer that you're currently connected to. So I'm currently connected to the Lambda server. This, yeah, most of you have probably only worked with one, maybe two computers at a time before. But again, when we're, our goal here, what we're building up to is working on like controlling an army of 1,000 computers at once. And so it becomes useful to have this information available to you, like what computer am I currently connected to when you're working with lots of machines. So that's what to the left of the colon is. To the right of the colon over here, this is my current working directory, PWD. We'll match this up here. But anytime you see a tilde in a path, tilde is short for whatever your home folder is. So this right here is my home folder, just /home/my username. And because most of the time you're working in your home folder, it's convenient just to use tilde to represent this whole thing. I can always do cd tilde. Anytime I'm actually typing in a path, I can use tilde to get there. So cd tilde is the same as cd. And another, so if I want to get back to where I was before, I could actually type that out again, cd proj /cmc dash whatever. Or another handy trick for navigating the terminal is that if you do cd dash, it takes you back to wherever you previously were on the command line. So these two commands right here, they look very similar to each other. But over here, this is a tilde right here, the squiggle, and that takes you to your home folder. This right here means the home folder. A single dash by itself represents whatever folder you were previously at before. So this command will always do the same thing every time you run it. This command will do something different every time you run it based on whatever previous commands were run. Okay, the actual question though is what was this purple thing over here? You'll notice, so I'll just do cd dash again to get back to where I was before. There is no purple thing over here in my home folder, and there is a purple thing in this Git repository. This purple thing will only show up for Git repositories, and it's the current branch that I'm currently working on. For the class repository, the default branch is 2023 Spring. And so that's the branch we're currently on, and that's why it displays that there. I've taught, I guess this is the third time this class has been taught. So there's 3 other branches in the GitHub repository. And but it's currently 2023 Spring, so that's the branch that we're working on. Various times on other projects, maybe not so much in this class, but there will be some other projects that have different branches that you'll be working on, and different things will display down here. Good question. Did that answer your question? Somewhere in there, maybe? Yeah, so in the lab, the default branch was the master branch that you were working with. This is effectively like the master branch, that it's the main branch that we're working with. This particular project happens to not have a master branch though. All branch names are just pointers to commits, just synonyms for a hash number. And yeah, the details of it, not super important. That's just what's going on there. Good question. Any other questions so far? Yes.
When you call the repository, it's like files that are repositories so far. You start updating the repository.
Yeah, so the question is, when you clone the repository, it gives you a snapshot of the repository at that instant in time. What happens when other people are making changes to it? And we probably won't get to that today, but Wednesday we'll talk about that. And in your lab for this week, you'll have to deal with that and resolve it. Yeah, there's a lot of steps with working with Git, and at this point, some of those steps will just be like rote memorization. You just have to do it, not understand why, but it's those eventual long-term situations that we'll deal with that require all these individual steps. So good question, but hold on to it for a bit. So at this point, we've done this step 1 and step 2. We now have the material on the Lambda server, and we have to make the changes to the file on the Lambda server. Again, the change that we're trying to make is I'm back now on the GitHub repository on the forked version, and it was under grades. Where did you go? Right here. Line 4, we wanted to change line 4 to be something more reasonable. Anytime we're editing a file on the Lambda server, then we will be using Vim to do so. So I'll just type ls again, always safe to type ls. And this readme.md file is what contains our syllabus. And so we're going to use Vim to edit the readme.md file. So Vim space readme.md. And again, I am super lazy. I don't want to have to hold down the shift key with my pinky and type out all of those letters. That's I have a weak pinky. I don't want to do that. So instead, I will just type out an R and press tab, and that's called tab completion, and it will complete the file for me without me having to type that and risking making typos and things. So Vim readme.md, and now it's opened up the markdown source code for our syllabus. Every repository on GitHub should have a README file. It's common to have readme.md if you're using markdown formatting, or just README if there's no special formatting. Very rare to have something like a .doc or docx. Those would be extremely rare. Vast majority of things are either README or README.md. And again, when you're inside Vim, the one thing that you absolutely have to know is how to get out. So :q quit. I'm going to go through a handful of useful Vim shortcuts now in order to make this change happen. You're probably going to, so you'll be spending more than 100 hours in the terminal this semester. Probably more than half of those will be inside of Vim. And so getting some familiarity with all these Vim shortcuts is going to be very useful for you in the long term. Vim is going to seem extremely annoying and frustrating at the beginning because it is just a weird thing, as you've seen. But maybe a month from now, you might start liking it. And by the end of the semester, hopefully you'll be more productive in Vim than you would be in something like VS Code. So the first thing is that, oh, this is a really long file, and I could like try to use the up and down arrows or something to try to find the location that I need to edit, but that is not efficient at all. And we care about efficiency in this class. We want you all to be lazy, to do as little work as possible in order to get an A in this class. That is my goal, for you to do as little work as possible in this class. Probably all the other professors are trying to get you to do as much work as possible, but they are wrong. We should do as little work as possible. And so we're going to search for the right line that we want to edit and let the computer do the work for us. We are computer scientists, so we make computers work for us. And so this is the line that I want to edit right here. And so I'm going to search for this little string for exams. In Vim and in every actual terminal system, the way that you search is with the slash key. So slash is the shortcut for search on basically every system that's oriented towards programmers. So that's certainly every terminal application, but even things like Firefox, slash is one of the hotkeys for searching. So if you type slash right here and then for space exam, it'll jump you down to this line 216, happens to be where that particular code is. And you can see there's a handful of other like things that I've commented out from previous courses in here. So it's not particularly well formatted, but anything inside of these HTML comments right here are things that GitHub won't render. So I tend to keep a lot of notes to myself inside of these things. And so what we're actually going to have in this class, not 4 exams, but a more respectable 2 exams. And instead of worth 256 points each, they will be worth 64 points each. Possibly less than, so I'll say less than or equal to 2 to the 6 points each. I did those edits without actually explaining what I was doing. I want to verbally tell you all the different commands that I'm talking about in Vim so that you can just see the way that I'm thinking. Sort of the naive way of doing this in Vim would be to, so right now you can see that I'm in normal mode in Vim in the bottom left-hand corner down here. It does not say the word insert anywhere, so that's how I know I'm in normal mode. I could go into insert mode by pressing I and then typing out what I want, press 2, then the delete button, and then move the right, right arrow, right arrow, right arrow, right arrow, delete 6, whoop, 6 like that. But that is a lot of keystrokes, so I don't want to do that. I'm going to leave insert mode right now by pressing escape. Escape, I'm going to press U for undo. That's how you undo things in Vim. So I'll back up with U until I'm back to how we were. We'll go all the way to, it's saying down here, already at the oldest change. So I just hit the U key a bunch of times. And then in order to change this 4 to a 2, the R key stands for replace. So I'll press R2, replace the thing under the cursor with a 2 instead of a 4. And now I don't have to leave normal mode in order to do that. So I can instantly type the command that I want to do next, which is going to move my cursor directly from this location over to this 8 over here. I don't want to have to press the arrow key a bunch of times. That's way too much work. That's like 15 keystrokes or something. I'm going to do it in 2 keystrokes. I'm going to press the F button. F is short for find. F, and then the letter that I'm trying to find is the number 8. So F8 moves my cursor from where it was to wherever the next occurrence of the letter 8 is. And now I'm going to change that 8 to a 6 by pressing R6. So again, those commands are things that are on your cheat sheet. It's worth looking at the cheat sheet to get a sense of what are the range of things that you can do on Vim. Those commands are also in the Vim tutor command, working through that. And Yeah, there's nothing, again, to turn in with using the vim tutor command, but you're going to be writing a lot of code in this class, and the more proficient you are at using the tools that you have, the easier it will be to write all that code. It's also the sort of thing that when you are working at, or when you're interviewing at another company, if, I don't know, there are certain tools and workflows that if I see somebody using, I have a very strong prior that they're going to be a highly successful person to work with. And somebody who is using Vim and knows the Vim shortcuts, that's like a really strong signal to potential employers that you are a very quality person that they want to hire. So nobody's going to like explicitly say that they hired you because you're using Vim. But if you're showing this use of advanced tools like this and being productive, that's just a really strong signal that's going to make people like not even think about the actual justifications for hiring or not. And again, these sorts of things, you don't have to memorize all the things that I'm saying in class about these little tricks. Just try to absorb as much as you can. Down here, all non-seniors, and actually I should say non-graduating students. My cursor is right here right now. I want to get it over to the seniors right here so that I can change it. The easiest way for me to do that is I'll press / to search and then SEN right here, enter, jump like that. I could have used the arrow keys to move, but it's just like a little bit faster there. And now I want to delete this word seniors and take me into insert mode. I'll press the C button. C is short for change, and then E tells me where it's changing up to, and that both deletes the next word and puts me into insert mode. So, and then it's actually non-graduating students will complete a final project due during finals week. So there's not going to be a final exam in this class, but there will be a final project for students who aren't graduating. Again, the particular command that I did right there was C for change, C short for change. And then all of these, we call them verbs in Vim. All these verbs like C or R, you can specify a length of those verbs, how much they are going to operate on. And E is short for from your current cursor location to the end of the word. So CE deletes up until the end of the word, and then you can type in whatever you wanted to type. Non-graduating students will complete a final project during finals week. One last thing to change here is that I have these little HTML comments right here. I don't want them in our final syllabus for this class. And so I'm going to delete those two things. Here, I'm not going to use any special command to move my cursor up. I'm just going to press the up arrow. But to delete a whole line, the easiest way to delete a line in Vim is to press the D button twice, lowercase d, dd, and that deletes a line, and then down, dd. And so I don't know, that was less than 20 keystrokes to make all those changes. If I was doing that without explaining everything, it would have happened very quickly. And again, the more comfort you get with these different Vim commands, the more fun it will be to work using these tools and complete the assignments. So escape, WQ, back to normal mode, write and quit. And now we have successfully edited that file. If I come back over to the cheat sheet right here, then we have already completed this step 2 of cloning down here. We're on step 3 right now. We've Vim file right here. We've edited the file in Vim. And there's 2 last things that we have to do in order to commit that file. Anytime you make changes to a repository using Vim or any other tool, anytime you make changes to a repository, there's 2 steps that you still have to do in order for Git to know about that change. The first is you have to add the file, so git add right here, and then you have to commit the file down here. Anytime you use git add, you'll want to use git commit as well. And anytime you use git commit, you'll want to use git add. So back over here, if I run git status is one of those idempotent commands. It's always safe to run, doesn't modify anything about your repository. So it's a good tool for debugging, just figuring out what is the status of my repository. And here you can see that this file right here is not staged for commit, so it is in red. And the git add command will convert it from red to green, adding it to my staging area like that. Git status, added it to the staging area, and then the git commit command is how I actually tell Git to create this commit, to save this state for the future. And this -m, whatever comes in the quotation marks over here, is intended to be the commit message. There's sort of lots of different philosophies about commit messages. In this class, you're never gonna be graded on a commit message. But here I'll just say something short like modified exams, like that, and hit enter. And this 3-step procedure, running vim on the file you want to edit, then running git add, adding that file, and then running git commit, that 3-step procedure corresponds to this step 3 of the pull request workflow. Questions? I saw a couple questions over here. Yeah.
I was thinking, in the branch that code, updating like
So the question is, over here, there's these different symbols, and what exactly do these symbols mean? We talked about the stuff to the left of the equal sign already. This is the branch name. The equals right here means that the branch is currently, like whatever is in your current branch is also online on GitHub. The star right here means that you have things that are not staged for commit. So you have red things over here. The plus over here means that you've gone from unstaged to commit to have it being staged for commit. So the plus equals and plus equals right here means that if you run git status, you'll get something green. The star means that you'll get something red. And then the greater than sign over here means that we've finally committed things. But this branch over here is ahead of the branch on GitHub. So it's greater than GitHub. You'll never actually concern yourself with these things, the meaning of these things in this class. But my particular prompt here, I have it configured so that it just has that information. So I have it at like a quick at a glance sort of thing. But you won't have to rely or memorize on those things. A good question. Kevin.
So I noticed that we have like 2 files that
Yeah, so it's a great question. The question is, up here, I added only a single file, and what happens when there's multiple files that I want to commit, and do I have to commit everything? We'll go ahead and walk through that. So if I type ls down here and git status, you can see, so here's the files. We haven't created any new files. Down here, it says nothing to commit. The working tree is clean. Working tree is clean means that all the files that exist are currently committed, saved somewhere in the Git repository. Let's just create 2 files real quick. We'll do vim example1, and up here we'll say this file will appear on GitHub, escape:\wq to save that. And then vim example2, here I just press the up arrow to get back to my previous command, and then deleted the last digit there, going from a 1 to 2. And we'll say this file will not appear on GitHub, escape:\wq. Now, if I run git status, then we have these 2 red files right here in the untracked files section. And I'm only going to add one of those files, git add example1 right here, and run git status. And so only one of those files got into the staging area. This other file down here, not in the staging area. Now, if I run git commit -m added example1, and git status, you can see that this example2 is still in this untracked files section. So Git doesn't know anything about it, but example1 has been committed. If I had made even more files, I could run the git add command multiple times and add more files at once. But because this example2 file right here is not, we haven't told Git about it in any way. When we push things from the Lambda server to GitHub, this file will not go, but example1 will go. So that brings us to this next step right here, step 4, how we get something from the Lambda server, off of the Lambda server, onto the back onto GitHub. And that's this command right here, git push origin master. Technically, so I have the most common version of the command written out right here, git push origin master. But this origin right here, technically what it's supposed to be is it's the name of whatever repository that you are modifying on GitHub. So this, whatever you cloned from is traditionally called origin. So this one is vast majority of times origin. And then the rightmost thing over here is the branch that you are currently working on. The most common branch name is master, so that's what I've written here. But the current branch that we're not working on, the current branch that we are working on is not called master, so we'll have to change this to our current branch. Come back to the command line right here, and we'll type git push origin. Always the vast majority of times you'll want origin right here, like 99% of the time. And then similarly, the vast majority of time, what you'll put over here is whatever the branch name is in parentheses. This is where you're putting it online, and this is where you are, what branch you're doing. Git push origin master. If you do that, it'll ask you for username and password information. This username is your GitHub username and not your Lambda server username. So if we do CMC example student, this is my GitHub username. That right there needs to match to, scroll up to the top again, needs to match this part right here. So CMC example students. And I'll hit enter. And then I'm going to type in my password for GitHub. And I promise I typed in that password correctly, but you'll see down here that this is not going to work. Whenever it says password down here, it's not asking for your password on GitHub. Instead, if you use your password on GitHub, you get this error message saying that password authentication support was removed on a couple of years ago, and so you can't upload things this way. Instead, what you have to use is the personal access token. And the pre-lab work last time asked you to create a personal access token for your account. I'm just going to go through the steps right now of doing that real quick. So clicking up here, going to settings, and then in the settings, coming down to the bottom left under developer settings. And then let's move Zoom out of the way. Personal access tokens right here, you'll be wanting the classic tokens. And then we're going to generate a new token right here. And it'll be a for general use token. If you missed any of that, the detailed instructions are on the pre-lab section, or you can watch the video again and pause it at the appropriate spots to follow along. And come on, I'm going to refresh this page. Oh. Firefox is being weird for some reason. Let's go back. Let's try again. I think Zoom is trying to click on that. Generate. Well, when you do that, it's going to bring up a big long password for you to copy down. It is impossible through GitHub's interface to ever get that password again. It is never going to display that thing for you. So you must save it to a file on your local computer so that you have access to it again. I'm going to bring up what that password looks like for this account for a previous personal access token that I've created. The way I personally store all my personal access tokens, so I just created a new terminal window here. Just have a hotkey for that on my computer, and I have a in just my home folder of my personal computer, I have files called PAT for personal access tokens. So Vim personal access token 2, open that. If any time you may have seen this sort of error message before when you're opening Vim, we'll talk details about that later, but I always just press this delete right here, press D. Here is my personal access token for this CMC example student account. And this personal access token, there's a lot of security related things for having it, but the most obvious is that this is obviously a more complicated password than most humans are likely to create for themselves. And this is forcing people to use very complex secure passwords when you're connecting to GitHub. So down here, I'm going to rerun my git push origin command. Actually, before I do that, just a reminder, where did this come from? After, if I was able to, oh, now it's working. There we go. Do that. press confirm. Down here, you want to set the expiration. So this is the information about what you want your personal access token to do. You want to set the expiration for at least 90 days so that you have it for the whole semester. Easiest is no expiration. And you'll want to make sure that you have the repo and the workflow items ticked right here. You don't need to tick any of the other ones. The note up here, it doesn't matter what this says, but you can say something like created for CS143. And then at the very bottom down here, generate token, and it displays you what the big complex password is. And again, you can never access this again through GitHub, so you have to save this onto a file somewhere and reference that file. Coming back over here, when I do the git push origin, type in my GitHub user account right here, CMC example students, and we'll copy and paste that password right here. When you paste a password, anytime you're working with passwords in the terminal, it's never gonna like display stars or anything. That's not gonna give you any indication that the information has been pasted. The information has in fact been pasted, and you hit enter, and now it shows that everything is working correctly. And I did in fact bring my power cord this time, so we can avoid any potential disasters. Down in the terminal down here, there's no real indication that you have uploaded things to GitHub. The only indication there is that greater than sign has now changed to an equal sign, indicating that what is on the Lambda server matches what's on GitHub. But if we come over to now our web page, I'll go back to here. And here you'll notice that I am still in the forked version of the repository right here, not in the upstream repository, but I'm in the origin repository right here. If we come down to the portion about grades, wherever you are, we can see that we have in fact changed this section of the README file of the syllabus. I'm going to now go back to the upstream repository. Click that, take me to the upstream repository, press, come down here for the grades, and you can see that we have not modified the upstream repository. You don't have permission to modify this upstream repository directly because it is my repository. Instead, you have to ask permission to modify the upstream repository. In order to ask that permission on your version of the repository right here, this is where you'll issue a pull request from, and that will connect your repository to mine. It will, if I accept the pull request, then it will modify my repository to make it just like yours. Here it's saying our branch is 2 commits ahead of the upstream. It's 2 commits because we made those 2 commits in the terminal. The first commit was to modify the README file. The second commit created this example1 file down here. We'll click on that real quick. You see this file will appear on GitHub, but there is no example2 file because we never added that to Git. Git was not aware of that when we did the push. In order to create the pull request, we press the contribute right here, press the open pull request. The title over here, whatever, and message, whatever you want me to see, we'll just say, remove exams, create the pull request like that. And now we have a little summary of each of my 2 commits available right here. And I can, when I'm logged in as my normal account, I'll be able to accept the pull request. And we'll do that here in a second. But the first thing I want to show us is that if this page right here is available to anybody in the world, can access it and look at it, and they can see exactly what these changes are that are being suggested. If you click on these hash numbers over here, it'll provide what's called a diff of the file that's being proposed to change. The stuff in red up here is what used to be in the file. The stuff in green down here is what we changed it to. If you've heard people talk about code reviews before, the main way that people do code reviews is on these types of pull requests. People look at the commits that you've made, and they look through this and say, oh yeah, this is what it used to be. That's way too much. This is the new thing. That looks a lot more reasonable. And so I think this should be accepted. If you want to leave messages on things, you can add a plus right here and say like, oh, 2 exams is still way too much. We should go down to 1 exam, and you're welcome to do that. I may or may not listen. Well, I promise I'll listen, but I may or may not agree. So in order to actually accept this pull request, I'm going to come back to my Firefox that is with my account logged in. And now if I refresh this page over here, this pull request previously has nothing associated with it. Now there's mine and probably a handful of other students following through, doing it as well. Here's my pull request right here. Click on remove exams. I see those same diffs right here. Before merging any pull request, I'll always look at these and just say, oh yeah, that's a very reasonable suggestion right here. And then down here, press that, and it actually merges the commits. And now our repo officially, our syllabus officially has us only taking 2 exams worth a more reasonable number of points. If anybody has questions about that, I'll answer them at the end of class. I just want to make sure that there's one last thing in the syllabus that we should cover today. And that's jumping down here to the academic integrity policies. This is related to a lot of the stuff that we covered in class this week and last week, and so I want to just discuss it. But first, the technology policy that you must complete all programming assignments on the Lambda server for this class. You're not allowed to just do it on your own local machine for whatever reason. You also must use Vim for everything in this class, that there are certain things that you could do with like the GitHub text editor. Like you could issue the pull request we just did through GitHub, but you're not allowed to do that. There are certain things even on the Lambda server that you can do through VS Code or these other IDEs, but you're not allowed to do that because we will get to situations where you can't, it's physically impossible to use VS Code to do it, and you must use Vim. And so I want you to get into the practice of using Vim before we get into those situations. You also may not share your Lambda server credentials, passwords, GitHub passwords, any of those things with anybody else. Any of these things which really are not at all applicable to other classes, so you might not think about them as normal academic integrity violations. For this class, they will be considered that. And then the collaboration policy. For GitHub issues, no restrictions on what you can post to GitHub issues. And in fact, I strongly encourage you to post lots of questions with detailed use of code and error messages. You should treat the GitHub issues like how you'd be posting things on Stack Overflow or other open source projects. And it's never a problem to post too much information on GitHub issues. In terms of collaborating in person with other students, there's 3 situations, 3 contexts that you're allowed to do that: in class or lab sessions, at the QCL, or in office hours. But outside of those situations, you're not allowed to work with other students. I know that's different than the policy I've had in all my previous courses, and I've gone back and forth about this, but I really want you all to be working together. I just want to make sure that it's done in a good environment. And this will actually, I think, encourage people to work together by coming together into the same spaces to work, and also ensure that the working together is doesn't exceed any sort of limits. Down here, the very last thing, all the things that we'll be doing in this class will be open source and posted to GitHub. So it's very easy to find other students' code and copy it. And but please don't do that. I don't want there to be technical restrictions on that. I want it to be purely social, because I want you to be able to easily share your code with future employers and have all the future employers like GitHub statistics gathering systems count all those projects. And so they'll be ranking you higher in their automatic rankings. So I'm trusting you all not to look at other people's code throughout this class. Very last thing about accommodations. There's lots of things that I've tried to do in this class to make it accessible to everybody. So for example, again, reminder, you have a quiz next class period. You can come early and have essentially as much time as you want on the quiz. I don't want anybody to be time limited on the quiz. But if there's other sort of accommodation things that anybody needs, don't hesitate to ask, and I will make that happen. I realize there's a bunch of people who had hands up and have questions to ask. I will stay after and answer any of those questions. One last quick announcement though, there is a, so we just talked about how to do the last part of the lab under topic 0. There's also a homework that's nominally due tomorrow, but and we've covered everything that you need for that. But there's no late penalties if you can't get it done by tomorrow for whatever reason. So try to do it, but if you can't, that's okay. I'll stay as late as people have questions, so make sure to get all those questions answered, but I don't want to go over time. So this is our official end of class, and good luck on your quiz preparations for Wednesday.